Hello, in this video tutorial we're going to be covering how to set up OpenGL using GLFW and GLEW on a Windows using Visual Studio. So first of all, what is GLFW? GLFW is an OpenGL framework. It's a very lightweight framework that allows you to detect events such as keyboard input, mouse input, that sort of stuff, and more importantly allows you to create a render window which you can render your OpenGL to, because with OpenGL on its own it doesn't have a way of just creating a window. You need something like GLFW. In terms of GLEW, that's the OpenGL extension wrangler that basically allows you to use OpenGL functions that are basically above 1.0. Anything that is new, or I would say non-core, or actually core is the wrong word because core is used in another context in OpenGL, which we'll be covering later on. But anything new, essentially, we need something like OpenGL extension wrangler. So we're going to be covering this on a Windows machine using Visual Studio. Don't worry, if you want to set it up on Mac, we have a separate video covering that, so check that out. First thing I would like to say is make sure you have a good foundation in C++, because this series will be using OpenGL with C++, and it's not the easiest thing OpenGL isn't. I will say that from the start. If this is your first time coding or you haven't been coding for long, I recommend doing C++, get a good foundation in it, then come back here. So now we got that out of the way. Now we need to download a few files. First of all, you need Visual Studio. You might already have it installed. If you do, fantastic. If not, just Google Visual Studio. Then go to the Visual Studio website. Just go to Visual Studio, download Community 2015. That's the version I have. Oops, daisy. Did I click on something? What the hell is happening? Visual, no, that does not look good. So yeah, actually let's just click more. It's taking me to the beta version, which I don't care about the beta version. I just want to download Visual Studio 2015 Community. So if I click download from here, you'll start downloading the file, which I'm not interested in because I've already got it installed. And once you've got that installed, you just want to make sure you set up the C++ side. Very simple stuff, but if you do have any questions, feel free to post them on our education platform, sonarlearning.co.uk. So once you've got Visual Studio installed, if you have the Pro version, that's fantastic as well, but Community will more than suffice. You want to Google GLEW, so we want to download the extension wrangler. Go to GLEW, you want to go to download, and you just want to download the binaries 32-bit and 64-bit. That will give you a compressed file. Once you've downloaded that, just unzip it and put it somewhere where you're happy with it residing, because this project and any other project that you create will reference that directory, so you don't want to be moving it around, because you will have to redo the settings on your project. Once you've done that, you want to go to glfw.org. You don't want to click download because it's for download the source code. What we want is the actual pre-compiled binaries for Windows. Select 32-bit or 64-bit. What I would say is, unless you know you need 64-bit, even if you're developing on a 64-bit machine, stick with 32-bit, because unless you think your game or your application is going to be using more than 4 GB of memory, then the 32-bit will more than suffice, and you'll maximize the compatibility. So once you've downloaded that, like I said, put it somewhere that you're happy with it residing. I've put it in my C directory, got a folder called OpenGL, extracted GLEW here, extracted GLFW. When you extract it, it won't be named as nicely as this, but I just renamed it to GLEW, took any versioning text off it and I put it as GLFW. It's just a little neater so we know what we're doing, and it's a lot easier to see. So once we've downloaded all of these, you want to open up Visual Studio. So my Visual Studio is Visual Studio 2015. Then you want to click New Project. You want to go to Visual C++, Win32. If you don't see any of these options, you might need to just download Visual C++. Very simple, you just click download and that will be done. You want to go to Win32 console application, name your project. I'm going to name it GLFW OpenGL. Click OK. Get this little pop-up that appears. Click next. Click empty project. Deselect the security development lifecycle. Click finish. Now you want to right click your project, not the solution, the project. Go to properties. My bad, sorry. You need to add a C++ file first. So you just go to add, new item, and this will be the main entry point. So I'm going to name it main.cpp. Now you want to right click your project and go to properties. If you try and do this properties stage of the tutorial before adding a file, certain options won't be available like C and C++ because it doesn't quite know what sort of project it is. So once you've got the .cpp file in there, go here. You want to go to C/C++, go to general, additional include directories, click the drop down, click edit, click this new button, click the three dots, and now you want to go to wherever you downloaded GLEW, open the include folder, click select folder, click new again, go to the three dots, go to the C drive or wherever you put GLFW, go to include, select folder, click OK. You want to go to linker, general, and what you want to do is go to additional library directories, drop down, edit, click new, click three dots, and you want to go to wherever you put GLEW. From here you want to select lib, release, Win32 or 64-bit, whichever one you're using. I'm using 32-bit. Click select folder. You want to click new, three dots, go to wherever GLFW is, and for me it's here. And with GLFW you got a bunch of different libraries that you could choose. You could do it for min.gw, different Visual Studio versions. Obviously I'm using 2015, so this is the one I'm going to be using. But there's a bunch of other versions, so if you have an older Visual Studio for whatever reason, you are covered. So just open this, click select folder, click OK. You want to go to input, and you want to go to additional dependencies, click edit. What you want to do is add OpenGL32.lib. This is built into the operating system. You want to do GLEW or GLEW32s.lib. This is the static library. If you don't want to statically link it, you can just remove the S. It is up to you. You want to add GLFW3.lib, not common lib.lib, and just make sure it's all named correctly. Click OK, click apply. Okay, there's one last stage before we can start coding, and that is if we go to the GLEW folder, go to bin, go to release, go to Win32. Again, you can go to the 64-bit folder, but recommend using the 32-bit stuff unless you know you need 64-bit. Copy this dynamic link library, go to your project, go to wherever your main.cpp file is located, paste the dynamic link library here, and now we are actually ready to start coding our project. So once you've got all that set up, you can just go to your main.cpp and, well, we can get started. So first of all, we're going to include, hash include. You know what? A lot of this is just getting in the way because we're coding now. I was going to click view, full screen, hash include. I wonder if this is big enough for you. So let me just zoom in. Well, that should be more than big enough now. So hash include IO stream. This is just the input output stream built into C++. We're going to do hash hash define GLEW static. So this is just statically linking GLEW. If you don't want to statically link it, just omit this define line, and you obviously need to write it correctly and not put defub. Not defub. You want to do hash include GL. See, it's picked up the folders / GLEW.h. You want to do hash include GLFW, GLFW3.h. I'm going to put this back to a /. Now we're going to create some constants, and this will store our width and the height of our screen, or not of our screen, our window, sorry. I'm going to do const GL int width equals 800, height equals 600. So you might be thinking, forgot to put an equal sign. You might be thinking, why are we using glint instead of a regular int? The thing is, with a regular int on different operating systems, for example, different compilers, the actual length of int might be different. With glint, it just keeps it consistent throughout. So that's just a great way of ensuring maximum compatibility. Next, we're going to set up our main entry point. So what we're going to do, first of all, we are going to initialize GLFW. So we're going to do GLFW init. Now we're going to set some window hints, which are essentially some properties that we're going to be setting for our window. First one is GLFW window hint, and it is GLFW underscore context underscore version underscore major, and I'm going to put (3). I'll explain what this does in a second. I'm going to copy and paste this. I'm going to change major to minor. So what we've done is set the version of OpenGL to 3.3. If this was a 1, it would be 3.1. But what it does is it doesn't explicitly set it. It just says try and set it to 3.3. If not, it'll fall back to an older version. So the next window hint we're going to set is GLFW window hint. We're going to do GLFW underscore OpenGL underscore profile, that one there, and we're going to put GLFW underscore OpenGL underscore. There's two main profiles that you will probably be using. It would be core profile or the compatibility profile, which is compat profile. So I'll explain the difference between the two and why we're using core profile. Core profile just uses the new OpenGL stuff, whereas compatibility profile uses the old way of doing stuff as well. Hence, compatibility ensures maximum compatibility. You might be thinking I've been hammering down on maximum compatibility, and now I'm saying don't use the one that ensures maximum compatibility. The thing is, this series and OpenGL, when you're learning OpenGL in general, you don't want to learn the old immediate way of doing things. You want to learn the new modern OpenGL using vertex objects, vertex arrays to actually store stuff on a graphics card. So if you do compatibility mode, you'll just get into bad practices and start using stuff like GL begin. So that is the reason we are setting it to the core profile. So once we set the profile, we're going to do GLFW window hint. We're going to do GLFW underscore OpenGL underscore forward compatibility. I'm going to set this to true so we get forward compatibility. This is required more for Mac because otherwise it will crash, but there's no harm in having it on Windows as well. So yep, that's fine. Next, we're going to set another window hint. So window hint, and this is going to be GLFW underscore resizable. And I'll set this to GL underscore false. So this just prevents the window from being resized. If you want it to be resized, just put true. Very simple stuff. Next, we're going to create our window. So for that, you put GLFW window asterisk window equals GLFW create window width height, just the title of our window. So I'm going to put learn OpenGL, and for the monitor and the share properties, or the window and the monitor variables, we're just going to put no pointers. We're not dealing with that in this tutorial. So now what we're going to be doing is doing int screen width, screen height. We're going to do GLFW get frame buffer size, and you want to pass in the window. You want to pass in a reference to the screen width. You want to pass in a reference to the screen height. And what this line is doing is getting the actual width of the window itself relative to the density of the screen. Most window screens, you could effectively omit these lines out, and when you create an OpenGL viewport, just use these two values. But if you have something like a Mac, like a Retina Mac, because it's not natively, I don't know, 1920 by 1080, for example, or that's just an example. Instead, if it was a Retina version or a higher density screen, it would be something like 3840 by 2160. It would mess up. It would only put the content like in the bottom left of the screen or in the top left of the screen, so it would only be a quarter of the screen. So this is getting the actual width and height of our window relative to any pixel density changes. So it's just a good line to have in there, and you'll ensure maximum compatibility going forward, because more and more high resolution screens are coming out. Now we want to check, is the window created successfully? We do that by saying if null pointer equals window, and in here we're just going to do std cout failed to create GLFW window std : and line. Very simple stuff. We're letting the user know, or the developer know, that something's gone wrong. Now we just do GLFW terminate anything that has been initialized, and finally just do return exit. You can do underscore failure, or you can do exit underscore success. I'm going to do exit underscore failure. Obviously you wouldn't want success because it's not successful. I don't know why I said that. Now you want to do GLFW make context current, and for the context we need to set it to our window that we created successfully. Next we need to enable GLEW. To do that, you do GLEW experimental equals to GL underscore true. And you might be thinking, okay, it says GLEW experimental. That sort of looks odd. Are we using experimental features? And I think it's a bit misleading, the word experimental in there. You have to set this to true, so GLEW knows to use a modern approach to retrieving function pointers and extensions. Basically, it's just a way of saying we're using GLEW the new modern way, but it's not experimental functions necessarily. Next, we're going to initialize GLEW and make sure it's successfully initialized in one go. To do that, you just do if GLEW underscore OK not equal to GLEW init. Inside this if statement, first of all, we're going to std cout failed to initialize GLEW std and line I'm going to do return exit underscore failure. Next, we're going to be setting the OpenGL viewport. So to do that, you do GL viewport. So we set the initial coordinates. You could set it to something 100 by 100, but I'm going to do it's going to range from 0, 0 to screen width and screen height. So again, you want to use the values that we retrieved right here, which are the accurate representation of what our window is relative to our screen, and not just these values that we've put in, because we might have a higher or a lower pixel density screen. So now that we've got that, we're going to create our game loop while inside here. I'm going to put exclamation mark GLFW window should close window. So basically what this is doing is checking while the window is open and not closing, run this loop. So this is what is going to be constantly run. We're going to be checking for events in here. We're going to be clearing the screen. We're going to be rendering OpenGL and all that other good stuff. So what we're going to be doing is doing GLFW poll events. We're going to do GL clear color. This is an optional line, but the reason I am putting it is if I don't put this, you just get a blank black background because we haven't drawn anything yet. I'm just going to spruce it up with some color. So this ranges between 0 and 1, very similar to ranging between 0 and 255, 0 being, well, no value, and 1 being full intensity of red, green, blue, and alpha. So we're going to put 0.2f, 0.3f, 0.3f, and 1.0f. Now we're going to do GL clear. This line is necessary to actually clear our window, so we're ready to draw the next frame. I'm going to put GL underscore color underscore buffer underscore bit, and after here is where you would draw your OpenGL stuff. But we're not going to be drawing anything in this video. That is reserved for a separate tutorial. So we're going to put GLFW swap buffers, provide the window, and now we're done for the while loop in this video. We're going to put GLFW terminate, because if you're hitting anything after the while loop, the window is closing. GLFW terminate and return exit underscore success, put a semicolon, and now we are ready to run this bad boy. So just click, where are we looking? Build, no, we want to run it, so run solution. Okay, I'll probably need to take this off full screen mode. Didn't run it. Let me just debug it using this button. Yep, it's running it successfully now. So here we go. We've got our amazing OpenGL window. Nothing much to look at the moment, but we're all set up on Windows for GLFW and GLEW for OpenGL development. Like I said earlier in this video, if you're interested on Mac development, then feel free to check out the Mac setup video. There are going to be some great videos coming out in this series. If you have any questions, feel free to post them on our education platform, sonarlearning.co.uk. There will be a link in the description to that, along with the link to our GitHub source code page, which will provide you the source code from every video in this series. If you like the video, please give it a thumbs up, hit that subscribe button, and leave us a comment. If you didn't like it, unfortunately, feel free to let us know in the comments as well. And as usual, thank you for watching, and I hope you have a great day.